Hello and welcome to my video lesson 6.4 on slope point form. So slope point form is very similar to slope intercept form, except that instead of using the intercept to find it, we are using a random point to find it. So basically, here it is, slope point form, y minus y1 equals m, which m is the slope, just like before. That's rise over run. Okay, and then bracket x minus x1. x1 and y1 are points on the line, or is a point on the line. Okay, so here's a question. Write an equation in slope point form for a line that contains those 2 points, or that point, the x and the y value, and that slope. So all you have to do is go y minus 3 equals 4 over 5 x minus 2. All right, I recommend that you try this out for the second one and see if you get the same answer as me. Okay, hopefully you paused it. Now I'm going to do it up front. So it's y minus 2 equals negative 4 x minus a negative 3. Now keep in mind that this simplifies to y minus 2 equals negative 4 x plus 3. So be careful about that. All right, so let's continue on. Write equations in slope point form for each of the lines shown below. So how do we go about doing this? So what we have to do is we have to find a point. So first of all, find a point. So here's a point, here's a point, here's a point, here's a point. Okay, so you can basically pick whatever point you want. I'm going to choose this point over here, which is negative 1 comma negative 1. And we need to look for the slope, which is going down by 3, and going to the right by 2. So negative 3 and positive 2. And there's our point. So I'm going to write y plus 1 equals negative 3 over 2 x plus 1. Okay, now you could use any one of the points on the line. I just happen to choose that one. I usually will choose the number closest to the origin point, okay, when I'm doing this. Okay, let's do this again, but now with the green one. So here are some of the points. Yeah, I mean, let's pick this one here. So we have the point 1, 2, 3, 4, 5, 6. So negative 6 comma 4. Okay, so that is our point. Now we need to find the slope. So it goes up 1, 2, 3, 4, 5. To the right by 1, 2. So that means that our answer is going to be y minus 4 equals 5 over 2 bracket x plus 6. Okay, now looking at the purple one, you can pick any point you want, but I recommend not using one on one of the axes if you can. So I'm going to pick this point here. Okay, and I'm going to find my slope. So 1, 2 down, 1, 2, 3, 4 to the right. So when I write this out, it's y plus 1 equals negative 2 over 4. Actually, now that I'm seeing that, I can see that I can simplify it. So I'm going to do that right now, actually. Negative 1 over 2. See, look at that. Negative 1 over 2. And then x minus 4. Okay, looking at the last one, the blue one here, we're going to find 2 points that are next to each other, so those two are good to go. Here's another one over here. So I'm going to pick this point, and it's going to be 3, 2. Okay, and it goes up 1, 2, 3, to the right by 1, 2, 3, 4. So that means we have y minus 2 equals 3 over 4 bracket x minus 3. Okay, that is 4 different equations that you can see here. But again, you could have had many different options here, so this one is kind of variable. But here, now that we're given an equation and being asked to graph the line, it is a little bit more, there's only one answer, okay? So I hope you pause the video right now, try it for yourself, and see if you can figure it out. I'm going to start with the blue one right now. Always start with the point or the y-intercept, okay? If it is y-intercept, slope point form, start with the point. Slope intercept form, start with the intercept. So here, our point is going to be -2, 3. So -2, 3, this is our point for that first function, the blue function. Then I use rise over run, so I go up by 5, over by 3, okay, and then I just do it in reverse, down to here, and hold on, I'm not far enough, there you go. There you go. So now that we have that, we can put the line in. You should be using a ruler to make a nice straight edge. Okay, now let's try the red one. So again, we have a function here, so it's 2, a point here, so it's 2, and then with a -4, so it's 2 to the right, and then -4 down. Okay, then we look at the rise over run. It goes down by 3, to the right by 4. So down by 3 to the right by 4. Down by 3 to the right by 4. So then we do it in reverse. We go up by 3 to left by 4. Up by 3 to the left by 4. Up by 3 to the left by 4. Okay, and then you draw the line. Okay, and the last one here, we've got -5, -8 as our points, so -5, and -8. Okay, that's going to be down here somewhere. I think it's this one. 1, 2, 3, 4, 5. Yep, it's this one here. And then the slope is 1/2. So it goes up by 1, to the right by 2, up by 1, to the right by 2, etc., all the way across. Okay, so now we can draw the line. Again, you should be using a ruler. I have this way of making the lines. Okay, so hopefully this one makes a little bit of sense, being able to graph the lines based off of the equations given. All right, let's continue on. We've got only 2 questions left. What is the equation of a line in slope point form that passes through the points that and that? I recommend pausing the video right now, trying both question 4 and 5 if you can, and then seeing if you get the same answer that I do. Okay, so we know that it's going to be slope point form. Your first step should be finding the slope, since we have 2 points. So what we're going to do is we're going to go y2 minus y1 over x2 minus x1. Whoops, 1. So our y2 is going to be 5. Our x2 is going to be 2. and then we're subtracting by our other values. So this is the negative versions here. So this is going to be 9 and 4, so 9 over 4 is our slope. Okay, so now that we have the slope, now we just pick a point. So it doesn't matter what you choose, but I'm going to choose this one because, I don't know, I find it easier. So y minus 5 equals 9 over 4, bracket x minus 2, and you're done. All right, let's take a look at the next one. It's more of a word problem, but you can read into it a little bit. Halfway of a 50-meter pool in 16 seconds. Well, basically, I would normally think distance versus time in terms of like this, distance versus time in terms of x and y. I just think about how normally I'd have distance on the y-axis and time on the x-axis. All right, so that's how that's going to help me out here, because now I can see that halfway across the 50-meter pool is 25 meters in 16 seconds. So what I write as one of my points is 16, 25. As the second point, I would write, well, it's the end of a 50-meter pool, so it is 50 meters. Okay, and it took 35 seconds. Okay, now realistically it's not a linear line, but we're pretending like it is, so we must not have started at time 0 because, you know, this wouldn't work out. But there is our, those are 2 points. We need to write an equation in slope point form. So what do we have to do? We have to find the slope first. Okay, so y2 minus y1 over x2 minus x1. So we're going to have 50 minus 25 over 35 minus 16. So we get 25 over 14. And unfortunately, that's where we have to stop. So now we can put it all together. We can go y minus 25, or actually better yet, not y. We should use d minus 25 equals 25 over 14, bracket t minus 16, bracket. So we put this in slope point form now, and that question is done. Part B, though, says using this equation, assuming a swimmer didn't slow down, how long does it take to get to 35 meters? Okay, pause it if you think you can do it, and we're at this step here. Okay, so now what you have to do is, well, we're trying to figure out how long it takes to go 35 meters. So we just take the 35 and you put it instead of d. So everything else is the same. And now you just have to do opposite operators, opposite bedmass to solve it. I mean, we can put this together first, but this will be 10, and then 25 over 14. This is going to be t minus 16. We can move the 14 and 25 over, so that'll be 10 times 14 over 25 equals, t minus 16. So I think 140, no, it won't quite simplify, but it'll be 28 over 5 equals t minus 16. Then we add the 16 to both sides, so t equals 16 plus 28 over 5. So 5, so 21.6 seconds. You could have plugged that in your calculator at the end there, that last step. All right, I hope this helps you better understand slope point form and how to graph it, and good luck.